All right, new day, and I have something different for us today. So this is an Alienware M18R1. Now, this one came in because it has a short on the DDR5 memory power rail. Now, this is happening a lot more often lately. And so I've been doing this modification, and I'm gonna show you what I do to help keep this area cool. What's actually happening is we have this power rail right here that's actually shorting out. So we're gonna modify this fan right here to allow some more airflow to come across here. Now, I've already taken a look at this, but let's take a look together and see how we can modify this cooling system. All right, so here's the board right here. I already removed it from the machine. What I want to show you is where it's shorted. I've already done videos on this in the past. So here's our DDR5 memory slots right here. And then this is our DDR5. It's a 5-volt power rail that powers the DDR5 memory. And so what ends up happening is we end up having a short on this power rail that powers the DDR5 memory. Now, if I measure right now, I'm getting about 1 ohm of resistance. That means that one of these capacitors are cracked. And I don't know which one it is. It's gonna be this one, this one, this one, this one, this one. There's a lot of them on here. These are all on that same power rail. I don't know what the total quantity is here, but a lot. Now, if we physically look at them, we may be able to identify which one's cracked. At this point, I'm not really concerned with which one is cracked. We can identify this really quickly. We put some alcohol on here, inject some voltage, and we'll be able to replace that part. Now, what I want to do is actually figure out how we can prevent this from happening in the future. And so the modification that I've come up with is modifying this fan right here. So this fan right here is actually a closed system, so it only blows out the side right here. It sucks in from the bottom, blows out the side, and it helps cool the CPU. So the CPU side actually has 2 fans, and the GPU side only has 1 because the CPU runs really hot on this machine. This is also cooled with liquid metal. What I'm seeing is that on these machines that we're having the DDR5 power rail shorting out is all these machines are overheating. That's what's really happening. Now these fans actually look pretty clean. I mean, they're a little bit dirty, but the odds are that there was a lot of heat in this area. So what we're gonna do is we're gonna cut the back of this fan open and we'll allow the air to actually flow out, and it flows right across here. It actually works pretty well. I was planning on building like some sort of ducting system, but it actually is not needed. Let's go ahead and resolve the short on this board first, and then we will modify the fans. All right, so I don't know where the short is. I don't know which capacitor it's gonna be. It's gonna be one of these. So what I'll do is I'll just kind of soak all these with alcohol. And if we cover them with alcohol and we'll just inject some voltage, we'll see where the alcohol is moving around. Now, like I said, I've been seeing a lot of these lately. It's all heat related. I don't know why I'm seeing so many of them. Dell even put a cooling fan on the DDR5 memory, but it only blows on this one side. It's not actually blowing all the way across. And so this stick will get hot still. But it's this section right here that actually gets really hot. So if I look at it when it's running, it actually is a very high temperature under the thermal camera. But what we're gonna do is we're just gonna inject some voltage here. Because the resistance is so low, we're just gonna reject right about a 0.5 volt. And if I put it right here, I can already see some alcohol dancing around a little bit. So I put alcohol over here, over there, and over there. And the only spot that I see alcohol moving is gonna be on this side. So that's where we're gonna kind of hone in on. And so let's zoom in there and we'll add a little bit more alcohol and we'll figure out which component it is. And we can actually just break that component off the board temporarily just to resolve the short. There it is. So it's gonna be this one in the middle, I believe. You can see which one is getting dry, and I'll up the voltage just a little bit. And you see how dry it's getting? All the rest of these are staying wet and that middle one's staying dry. So let's get that capacitor removed, show that the short is gone, we'll put a new one on, and then we'll modify the cooling system. The worst part about this is the worst one out of all the capacitors to be bad, is because we're in between all these different pieces of plastic. We try to put a soldering iron down here. We're gonna start touching these things. Using hot air is a little bit hard. We're gonna be able to use a little bit of hot air to warm up the board. We're gonna use some hot tweezers to get down in here, but we're gonna need to protect all this plastic so we don't end up marring it with our soldering iron. So I'm just gonna put a little bit of Kapton tape everywhere. All right, that will just help protect me from just accidentally touching the edge with the soldering iron. All right, so now that I have all that protected, I'm gonna use some low temperature hot air and the hot tweezers to remove that capacitor. You could just break it off, but that's a little bit harder to do. Like if you did that, you could just kind of pry in here and just kind of try to break it off. And it doesn't really rip the pads usually, it just kind of comes off the board usually because it is cracked anyway. But we're gonna just lift it off because we do have hot tweezers and hot air. And so we need to use this in conjunction. If we were working on a smaller or thinner board, it would be a lot easier. These hot tweezers are pretty good, but they will not produce enough heat to melt the ground track or ground pad on this board. So I heat it, this is 300 degrees C on the hot air station. And then we'll just grab this with the hot tweezers. It should come right off. And you add a little bit of flux. All right, we got that off of there. So hopefully the short is resolved, and it should be. So I've worked on tons of these. All right, so now we'll go back and measure this inductor to see if the short is gone. And the short is gone. So we no longer have a short on the board. Let's just put a new capacitor on there real quick, and then we can continue with our modification. Again, this is very tiny and very hard to get into. And so we have to put some fresh solder on here, or else we won't be able to solder the new chip on there. There we go. If it blobs up, it's okay. We can pick up any extra excess later. Not too concerned with that. Okay, so we have enough solder on there now. And all these pads are kind of connected together anyway. All right, so we'll grab a new one, which is going to be these. It's going to be a 0402. It's a 22 microfarad 6.3 volt capacitor. And you see how many I've replaced? All right, so we're just going to install it just like that. Now that we have the leaded solder on here, it actually melts at a lower temperature. It's a lot easier to use a little bit of hot air. We're not using high temperature because we don't want to melt any of this plastic stuff around here. There we go. And that's all done. We'll just do a little bit of cleanup after ourselves. All right, now I know I sped through that really fast because that's not what the video is about. It wasn't about fixing the short here, because I've done that plenty on other videos about this exact machine. Now it's about modifying this fan. We will need to pull the heatsink and fan off. I am putting PTM 7950. This thing was shipped with liquid metal. We're going to remove that element 31 liquid metal off of here. We're going to put PTM 7950, and we will be modifying that fan. So let me go ahead and get these removed. All right, now I want you to be careful when you're taking this off, so we're just going to lift it off slowly. We don't want any drips from the liquid metal. And lift it off slowly. And it actually looks like it was applied perfectly. And it looks like we only have liquid metal on the CPU, but it looks like it's actually not even the element 31, which is kind of a mix between thermal paste with liquid metal. It looks like it's just plain liquid metal. And this one looks like it is the element 31 liquid metal, actually. So that's the mix. Now I'm wondering why we have just plain liquid metal here. Did somebody reapply the thermal paste on here, the liquid metal on here? I may need to stop and talk to the customer, or maybe he wants me to keep the liquid metal on there. Some people want that. But let's go ahead and modify the fans. All right, so we're gonna have to take apart these fan assemblies anyway because we need to clean inside of them. A lot of times you'll have a bunch of fur in here and you can't tell. And I can see there's a little bit of fur on these actual fans if we look closely. You can see that there is some debris that is built up on here. Now, we don't know how much is built up back here because it's all hidden, and that will reveal itself after we remove the fans. So this side's actually the easier side to get off because it doesn't have two fans. These fans are hooked together, so we'll have to remove that bonding screw. And that takes a little bit more of a process, but we're just gonna take this one off. And we're not modifying this one, we're just gonna clean behind it. So what I like to do is there's a tape on this side, there's tape on this side. If I just untape this side and use it as a hinge, then we can reapply the tape. Now these don't actually look dirty back here. I'm actually surprised, but I will toothbrush it still and blow it. So use your toothbrush wisely. Brush in there, and then we wanna brush all of the blades in here. And inside of here, I'll clean that out. And then we'll brush this, and then we'll go blow it all. I'm surprised. This is actually pretty clean, but it almost looks like it has been cleaned in the past, like it was taken to another shop or somebody cleaned it. The owner maybe cleaned it. So let me blow this side out. Okay, that side's done. So this side's the more difficult side just because there is a bonding screw that actually hooks them together and it's captive. And so you can do it two different ways, and I've tried either way. We can actually try to keep these attached, and maybe we'll try that way on this repair so that way we don't have to take them apart. I'm gonna go ahead and put these screws back in so this one is not flopping around. Now the screwdriver you're gonna need to take these screws out are gonna be a number 0 screwdriver. The regular screwdrivers you need to take all the rest of the screws out is a number 1, Phillips. All right, so the big fans have 3 screws, and this small fan has 4 screws. Trying to keep track of all the screws. I'm not mixing them with all the rest of the screws for the system because I'm just gonna put them right back in. I don't wanna have to dig for them. All right, so here's the tricky part. So because these are kind of hooked together, we're gonna try to get this untaped here. There we go. And that just came right off. And then we're gonna flip this one up too. So we gotta get this sticky tape undone just on this one side so we can lift it up. There we go. All right. So it doesn't look like it's ever been opened before, but it is really clean because this tape would have come undone a lot easier. So again, we're going to toothbrush this and try to clean it. Clean all the fans. There's really not much to clean though. I gotta say, it's actually a lot cleaner than I've seen on these systems, especially with this issue. Prior machines that I've worked on, I've actually pulled out big sheets in here, so I'm actually very surprised. All right, let me blow this out. Blow this one out. Okay, so that's all ready to go. That's all clean. And actually, I can put these screws back in on this one. All right, so that's ready to go. So here's the fan we need to modify. So the plan is that what we're trying to do is we're trying to get air to blow out the back here that goes across the motherboard. And so the way this is installed, it's installed like this. And what we want is we want the airflow to come through this little slot here and cool the board. Now I've done this on a number of systems and tested it prior. I've done thermal tests on it afterwards, and it actually does keep a lot cooler. Now when this spins, it's gonna be blowing air right through here, and then we're using both of these as a channel, so it actually pushes the air through here. So we're gonna cut it up to this line right here, but we don't wanna cut it past this other line. So in general, you can score it. You can take a, let's see, razor blade. You can take a razor blade like this, and you can score where you want it to end, right? So I just do a score there, and we'll do a score here. And we can see where we want to do it. We have a mark right across there. And so if we score it, then we make sure it's not going to go any further. Like that. And then we do that. We just don't want it to break more than we need to break. And the way I break it is I just use a pair of side cutters. So if you have these side cutters, they're cheap. I love them. And we're just going to set it in there like this. Let's see if we can get a good view here. Set it in there like that. I'm not going to cut all the way to the end at first. And then we're going to cut all the way over here like that. And see, the piece just flies right out. So now we actually have an opening here. And so when this fan's going to spin, it's going to push air right through here, and it's going to become a channel that pushes all the way across. And so now we've modified this fan to help cool the motherboard to keep those capacitors cool, because those end up cracking over a period of time. This modification, I haven't seen a single laptop come back. So I'm hoping it's going to be a permanent fix, but you never know. And all we're trying to do is just trying to improve the performance. So that's what we're going to end up doing with this one. So let's get this reassembled. Actually, let me call the customer and see if he actually wants to keep this liquid metal. Sometimes people have preference on that, and I'll be right back. All right, so I just got off the phone with the customer. So he would like to proceed with putting PTM 7950 on there, which is going to be a thermal phase changing pad, and it's made by Honeywell. And they actually have the thermal efficiency similar to a liquid metal, but it's safer. Liquid metal does leak everywhere. Now on this one, I don't think there was an issue with it about to leak or anything like that. But once we pull it apart, we're gonna have to kind of, set it back together properly. So doing the PTM while it already is apart is a good idea. So let's go ahead and get this cleaned up and get the PTM installed. All right, I got the heatsink all cleaned off. Let's grab the motherboard and get that cleaned up. Now I want you to see the difference here. So this is element 31. So this is gonna be a mix of thermal paste mixed with the liquid metal. And this is generally what Dell uses. I'm not sure why we see something different on the CPU. We just need to make sure to collect this and put it in the trash right away. This is just straight liquid metal, looks like. Maybe it is element 31 still. It just looks like it's mainly liquid metal, but you can see that there's a little bit of thermal compound mixed in there. Maybe it's just mainly liquid metal. Interesting. But anyway, yeah, we're cleaning this stuff off. This stuff does work very well for thermal conductivity, but it's just not safe, and I'm tired of having to clean it up. So I'm just using a Q-tip. We're just using a lot of Q-tips is generally how we do it. And we just want to pick up as much as we can on each pass and then throw it out. I'm actually just going to break the Q-tips in half. That way I have a little bit more to use instead of having to waste it. All right, I got that cleaned up. Put a little isopropyl alcohol on here just to finish it up, and we should be good to go. All right, so the CPU is ready. All right, we'll finish up the GPU now. I wonder if there's different consistencies of element 31. I've never used it before, so I don't know, but like I said, this one looks more like heatsink compound and a little bit of liquid metal, and the other one looks like more liquid metal and less heatsink compound. So I don't know if it was just a different part of the vial, it was like separated or what. And this looks like this is a 4090? It is. This is a 4090. Well, this chip runs really hot. RTX 4090 on a laptop is definitely a hot chip, so we're going to make sure we put the PTM 7950 on here. All right, and then I can see a little bit of remnants of this liquid metal that's kind of like stuck on the die itself. You see the chunks there? So we have to kind of break that loose with some isopropyl. Scratch it a little bit. There, a fingernail. We don't want to use anything too abrasive, so a fingernail works perfectly. Let's try wiping that back off. Okay, so that's ready. All right, so we actually sell these Thermal Grizzly PTMs, and so we have these, they're smaller sheets, and so I have these, I have the link in the video description, but I buy big giant sheets of it because I have to do large quantities of it, so but if you want to pick up some of that PTM, you can pick up the Thermal Grizzly's version of it. And so what I'm going to do is line this up on the chip, and we'll just rub the outline, and then we'll cut it out. So I just kind of rub it with my fingernail. And then you can kind of see the shape there, and I'll cut that out. And then this has a film on either side. I just kind of peel whichever side wants to come undone. I peel it off of there. And then we're going to set it on the chip. Now, I know a lot of people say you can do it undersized. I actually like doing it oversized personally. And the trick to make this come off properly is you want to rub it really good here. And you can actually use your fingernail to rub the edge of the die of the core, and then it will actually cut it for you to the right size. So if I do this, so now when I peel it off, it should actually just peel off and have the right size there. And there you go. Sometimes it cuts off a little bit of the excess, but it's covering the chip completely. The main core is like right there, and then we have a little extra piece there. But you can see that where I rubbed it with my nail, it actually cut the excess that we didn't need. So we'll go ahead and get one done for this side too. Just line that up, scratch it, and cut it. Now, again, the real trick is you have to rub this on here really hard, or else you're going to have issues with it coming unstuck when you try to peel off this top layer. And I know that people had a lot of issues with that. There you go, comes right off. Now this phase changing pad will actually turn more liquid and spread out and fill all the gaps whenever it heats up. And so that's what is kind of innovative about its technology. So you don't have to be super precise on it. We'll get that lined up and bolted back on. All right, the heatsink is on. Let me install the motherboard. All right, I got the motherboard installed with the new fan modification. Let's see if it does turn on. I haven't actually tested it after we replaced that shorted capacitor. So let's see if the power rail is not shorted anymore. We are getting the keyboard backlight. It is jumping around all crazy, but I guess that's the pattern they have programmed. Keep an eye on the power meter here. We are pulling, it looks like about 3 amps or so. So the startup process on this takes 3.5, 4 minutes to get through a CMOS reset on an Alienware M18R2. So I'll be right back. All right, so the laptop does turn on. It is booting the Windows, and I'm gonna boot the diagnostics. Let's see what those temperatures are looking like, and then we can actually look at that modification. We can actually trigger that fan to come on and start blowing, and we can see kind of the airflow there, and then I can kind of show you exactly what that's doing. All right, we're booted in the diagnostics, and it looks like it is sitting right around 76 for the CPU. There's actually 2 CPU sensors, so I think one might be the hotspot, and then one's going to be the regular CPU sensor. So 67 to 76. Now, I haven't run like a full stress test on this thing, but the resting temperature on these laptops are usually pretty hot, or at least a hot spot that I've seen in the past. Now, the fan that we're looking at here, it's actually called the memory fan. I believe they have them kind of labeled backwards, because there are 4 fans in this machine. You have one that blows the memory, but if I triggered the memory fan, it actually spins the fan that we modified. So we're actually using it as a memory cooler now, which is ironic. So right now it looks like the 2 main fans are on, but we don't have either one of those extra fans are on. So if I come over here to an advanced test, I can choose which fans I want to trigger on. So we're going to trigger on the memory fan, wherever that is. Right here. I'm going to do a thorough test, which still will be pretty short, but we're going to just run that, and we can look at it spin. So here's our modified fan right here, and so I'm going to turn it on right now. Is it actually on? Yeah, it is on right now. Here's the memory fan itself, but that's not on right now. This is the one that's labeled memory inside this interface here, so I'm going to go ahead and run that test. And you can see it spin up, and it passes all the tests. And so the airflow is going to blow right here, and this is the power supply that's actually been failing. So that gets hot, and this is the capacitor we replaced, was right here, but it could be any of those. And so because this airflow is going here, it actually is keeping this area a lot cooler. And I'm going to run the other test. We'll just do all the fans tests real quick. So I'm running all 4 fan tests. So we should see each one of them spin up. So both sides are spinning up now, and then this one just spun up right here, the memory one, and then this one just spun up right here. So all the fans have passed the test, and the laptop temps are looking good. So I'm glad I was able to share this with you so you can modify your fans yourself. Now this is going to be relevant to the M18R1 and the M18R2. The M16R1 has kind of the same setup, so you could do it. I haven't done it on the 16R1 as much, but the 18s are the ones I generally do it to. I'd love to know if you've done this modification before, or if you would try this, and thanks for watching.
I saved another laptop!